Hey folks, we're going to do a short little video lesson on coterminal angles, and then you'll have some radian and unit circle practice. So let's do a quick review. We talked last time about drawing various angles, okay, and what positive and negative conventions are. So take a moment and draw the angle 250 degrees. Okay, we'll put that on a little coordinate plane here. And then also draw a negative 110 degree angle. Okay. And as you draw these, see if you notice anything. Alright, perfect. So hopefully you've had a chance to have drawn those angles. So 250 is not quite at 270. Remember, positive angles rotate counterclockwise. And negative 110, that'll be 20 degrees past negative 90. So remember, negative angles go clockwise, so I'm going to go right about here. Label that negative 110. Now we can definitely see for sure they both land in quadrant 3, and if we kind of remember, 250 is 20 degrees short of 270, negative 110 is 20 degrees beyond negative 90. These actually land in the same relative location. Okay, so there's a name for this. We call these coterminal angles. So those are angles that end in the same location. Coterminal angles. Alright, and we might recognize, just a little language lesson here, that the word co often precedes, it's like a prefix of things that kind of go together. Okay, so co means together, and terminate means many things, but in this context, terminate means to end, right? So these angles end together in the same location. You can imagine on the coordinate plane, right, there's many opportunities for coterminal angles to happen depending on how many rotations we're going through or what direction we're going to. So sometimes if someone wants to know a coterminal angle, right, there's actually an infinite number of coterminal angles with 125, but if we just want one negative one, one positive one, the easiest thing to do is add and subtract full rotations. So I'm going to do 125 degrees and add a full rotation, okay, in the positive direction. That'll give us a 485 degree angle. And if I want a negative angle, I can do the same idea, just subtracting a full rotation, and that's going to produce a negative angle of 235 degrees. So both of these are coterminal with 125, and then we have an opportunity to practice our angle drawing a little more and draw all three of them. I'm going to do them all in the same area. So I'm going to do 125 first. That'll be in quadrant 2. Okay, maybe somewhere like there-ish. Alright, so there's 125. And then my 485, that's more than a full rotation, so I'm going to do that kind of spiral that we talked about in class to kind of capture that. So remember, all of our angles start at the positive x-axis. And then the negative angle, the negative 235, that'll start at the positive x-axis and we'll go clockwise. Okay, so all sorts of angles drawn on that same plane, but we can see in all cases, and as we kind of already knew when we were drawing them, that they are coterminal, all landing in that same spot. We talked about radians last time. We got a little introduction to radians. So those are just different ways of thinking about angles. So if I want to find a negative and positive angle that's coterminal 2 pi over 5, kind of like we did with degrees, I'll do it with radians though, as I can add and subtract full rotations. So I can add a full rotation of 2 pi to 2 pi over 5. In something like this, it's helpful to get a common denominator, so I'll change 2 pi to be 10 pi over 5. 12 pi over 5. So that's our positive coterminal angle. And then if I want to do the same idea but just on the negative side, I can subtract that full rotation of 2 pi radians. Okay, so that'll produce negative 8 pi over 5. So that's our positive coterminal angle. There's our negative. Just like our previous example, our prompt is to draw the angles, alright, and we're still getting familiar with kind of what radians are and what they look like. So 2 pi over 5, remember 2 pi is a full rotation, so a fifth of that. So this is really a fifth of a full rotation basically. But if we want to kind of have a little bit of assistance in terms of drawing our angle a little bit more accurately, remember we can always do our conversion, okay? pretty soon you guys will be so used to radians that a lot of certain radian values, you'll kind of just know what they are. But let's go ahead and do a conversion here. So the pi's cancel, and we'll have 2 times 180 over 10 would be 18, and 5 is going to go into that twice as more times, so we'll have 36 there, 36 degrees. And we can check that too. 2 times 30 is... Oh yeah, 72. Let's see. Yeah, that seems right. Okay. Sorry, kind of lost my train of thought there. So yeah, 72 degree angle is the same as 2 pi over 5 radians. So when we draw this out, okay, we're kind of drawing, we are drawing a 72 degree angle, but really try and think about, oh, we're drawing 2 pi over 5 radians. That'll be in quadrant 1, maybe something like that. Okay, so there's our initial angle, and then our larger coterminal angle, 12 pi over 5, will wrap around for 1 full rotation. There's that. We'll keep going. Coterminal, let me extend our terminal ray a little bit more. And then our negative angle, negative 8 pi over 5. There we go. So a nice little angle review there. So at the bottom of this page here, there's just 2 examples for you guys to try. All right, 1 degrees, 1 in radians. Coterminal angles are very simple, but just the idea that, yeah, multiple angles do land in the same place. You guys can practice with that. All right, so I'll let you guys do that on your own. You can turn the page here. Excuse me. This page right here, just a little more practice with radians. You guys did a practice worksheet the other day where you did a lot of conversions. So I want you guys to be aware of a couple of kind of very common radians. That's this left-hand column right here. So pi over 6, pi over 4, pi over 3, pi over 2, and pi, and many others too, but these are kind of the basic building blocks as I think of them. Just come up a lot in different analyses here. So remember our conversions, we can multiply by 180 over pi or pi over 180 depending on which direction we're going, but in these examples we'll be converting radians to degrees just to help visualize. So I'm going to multiply by 180 over pi. My pi's will cancel, and 180 divided by 6 is 30. Okay, so 30 degrees is the same thing as pi over 6 radians. And so in this little box here, draw a sketch of angle, I'm trying to kind of exercise my brain here with this muscle memory. So I'm going to draw this angle here, right? That's 30 degrees slash pi over 6. But instead of labeling it 30 degrees, I mean, we've done that hundreds of times in our lives. We haven't labeled things with radians as much. I'm going to go ahead and draw a little pi over 6 here. And that's associating this value, pi over 6, with this kind of angle of rotation. So kind of getting that muscle memory in there. So as you guys go through and do each of these, okay, label it instead of degrees, label it in radians. This is just to help us realize kind of how far we're drawing. Okay, so if I drop down to number 3 here, pi over 3 is another super common value. You might already recognize it. 180 divided by 3 is 60. So pi over 3 is a 60 degree angle. So I'm going to go over to my little sketch here, draw a 60 degree angle, but instead of labeling it 60, I'm going to label it pi over 3, again, just so I start to associate that idea of that rotation with pi over 3. Another thing I want to point out is in this column here, there's some more angles here, and they're all in radians. I want you guys to start thinking about, when you see things like pi over 6, pi over 4, pi over 3, think of recognizing those radian building blocks. And so when you see something like 5 pi over 6, we go, oh, that's just 5 times pi over 6, which is a 30 degree angle, and we can change that to 150 degrees. Okay, so noticing these common multiples of these angles that we have. Okay, same idea for something like 11 pi over 6, right? That's going to be 11 30 degree angles all strung together. Okay, so that's equivalent to 330 degrees. So as you guys go and get your kind of crucial radian building blocks here, draw those sketches and find just a few more angles, okay? And then on the back of this sheet, okay, you'll see, I guess it's on the next page here, there's what we call a polar graph, okay? And it's just instead of a Cartesian coordinate plane with like x and y as the focus, this just focuses on degree measure, so rotation. So each ray, right, this is a ray, represents 15 degrees. So I have a couple of them pre-labeled for us. So this ray here, and I'll just kind of end it with a dot, just so you can see it a little bit more. That's what 30 degrees looks like, right, if I start at my x-axis and rotate up. And that's the same as pi over 6. Okay, on our sheet over here, right, we got that already, so that's kind of pre-graph for us, but I'll go ahead and add 60 degrees in pi over 3. Okay, so this would be 45. I can label that right now. Okay, we can get the radian measure in there, and right here this is 60 degrees slash pi over 3 radians. So again, this exercise is just meant to start to get us used to where those degrees are, where those radians are. In our other page here, I'll just bring that back for a moment. We learned that 150 degrees was 5 pi over 6, and so we did kind of a faster conversion method, kind of a shortcut. So I'm going to go over here to 30 degrees short of 180, right, and I'll go ahead and write 150 degrees, and that's equivalent to 5 pi over 6. So you can do the front of this page, okay, all the way through, then come over here, or as you go, if you want to add things to your picture. You don't have to fill out every single ray. 15 degrees isn't as common of an angle that we work with, but our 30, 45, 60, and all of those multiples, you can go ahead and write the degree and radian equivalents there. Okay, so at the end of this, you'll have not every single ray, but most of these rays will be filled out with their degree and radian pairs. Okay. And just to, again, really solidify some of those really common ones, okay, you guys can fill in the blanks down here. Crucial radian building blocks, fill in each blank. And on the very back side here, okay, is some practice with the unit circle, like we discussed in class. So bringing it all together, the coordinates on the unit circle, as well as I'm going to have you guys in the little ovals here fill out the degrees, and the rectangles you can fill out with the radians. So just another muscle memory there. Okay, so you guys can fill out this little packet here, all right, about focusing on your radians and unit circle, and we covered our coterminal angles as well. All right, great job.